section will be implementing hard drives, specifically when installing Windows OS itself and the actual steps that we need to take. Our ultimate goal is to be able to explain the purpose and the methods of hard drive partitioning, explain the purpose and the methods of the hard drive formatting, and identify the common issues that we may run into and the troubleshooting techniques that we can use. Learn here that overall partitioning means it is the process of electronically subdividing the physical hard drive into smaller units called partitions. Within Windows, it supports three different types of partition. We're used to the actual MBR, the Windows proprietary dynamic partitioning schemes, and the GPT, or what they call the GUID partitioning tables. Within this, we need to be very persistent, and obviously teamwork is critical when it comes to when we're doing this in the masses, and or if we have our doubts on what to use. Overall, there is specific tools that are designed to assist us in partitioning the actual process. Uh, Formatting does create now a file system. First, we said partitioning. So partitioning would be just like if you went in and created yourself a pizza pie and you went and created the slices themselves. But unfortunately, you didn't put any ingredients in there, so that's just useless, right? Formatting actually creates the file system itself, makes the root directory in that file system. Each partition and volume must have a format in order to be able to hold any data. Back in the days, we have the actual FAT16, the FAT32s, which evolved eventually to the NTFS, which had the security and compression capabilities, encryption, disk quotas. You also have the capability of creating your own cluster sizes. And lastly came the exFAT and FAT64. Hard drives can experience partitioning errors, formatting complications, or even physical problems. These can be resolved carefully by isolating and troubleshooting the actual issue itself. So, help
I'm
me here,
sorry, that was
please,
me.
Faison.
That was me. I'm sorry. I moved you.
The what?
Did I
No,
move your screen? Okay.
I don't think did you hit twice?
No, I didn't know if you hit once. I just tried
Yeah, I
to.
did. I
Okay. All
did.
right.
I I did.
Okay.
And thank you. I know there's a lag by the time I hit it and it shows over there, so no problem. So Faison, help me out here, please.
Sure. Partitioning is the process of electronical subdividing the physical hard drive into smaller units called partitions. A hard drive must have at least one partition. Partitions allow to use multiple OS in the same hard drive, one per partition. Windows support three partitioning methods. One, master boot record, MBR. Two, Windows proprietary dynamic partitioning scheme, dynamics disk. Three, GUID partitioning table, GPT.
Thank you. As we see here, the MBR itself, the master boot record, is the partition format that has been around since the early 1980s. Uh, Predominantly still being used by many Windows systems themselves. However, obviously it does have its limitations. MBR, for instance, can be installed within a partition and it's going to eat up the first 512 bytes on the hard drive. This is where the actual master boot record is going to be stored. After that, it can contain 4 partitions itself. But it itself can be a maximum, each partition of 2 terabytes. I was about to say gigabytes. Questions on an MBR itself? Now the latter one is the GPT itself. It is the one that is now being used by our UEFI BIOSes, which UEFI now can allow us to create much bigger partitions. You can divide up to 128 GPTs or partitions per disk. The GPT stores a copy now of the partition table on the first and last. We said earlier, the MBR does it in the beginning. So if something happens, boom, you lost a little Rolodex, or as I like to say in the library back in the days, when you go and look at that reference card, it's basically someone and throw away that reference card. The book is still on the actual shelf, but unfortunately, we're unable to reference to where inside this hard drive it is. The GPT eliminates, or at least mitigates that issue, that if you do lose something, you still have a backup copy of it. It also performs on itself a cyclic redundancy check or CRC to be able to verify the actual integrity of the actual partition. Questions? Windows proprietary one is the actual dynamic disk itself. That is their version of being able to create partitions. Obviously, we need to choose carefully depending on what we want to install here. These partitions will allow us to, that was just too cute, will allow us,
Why would you want to use the Windows proprietary one? It seems like the GYD, the GPT seems like the much better one.
The Windows proprietary one, it is a dynamic disk itself. You can use that within your virtual machines to create your own dynamic disks. Another features that the dynamic disks have are some capabilities that you can't do with GPT. For instance, in some versions of Windows, I believe, correct me if I'm wrong, guys, the dynamic disk will allow you to do the RAID configurations, while then the old ones may give you problem on some of your Windows versions. I'm not 100% sure on that one.
Oh, that is correct, because the operating system can act like a RAID controller. You will use more resources by doing so, but that's what dynamic can do. It helps with RAID if you have the license for it. I think for business, no, not business, pro, you can do RAID 1 and RAID 0.
So if you do a regular GPT, you would require most likely a RAID controller, and or once again, it all depends on which type of Windows you have installed, because Windows Server has more capabilities than Windows Home. As for the actual regular ones, that's your MBR and your GPT, depending on the size itself. The size of the drive. MBR is the old technology and is not being used pretty much at all lately because of its limitations. Any other questions on this slide before we proceed? Now we're going into the actual. Wow, I'm gonna have to share it over here because that's real. I hit it like a real long time ago. There we go. Hard drives themselves and or the partitions. David, help me out here, please.
Master boot record partition table. Hard drives using MBR partitioning scheme have a tiny bit of data in its first sector that is also called the master boot record. MBR also contains the partition table, which describes the number and size of partitions on the disk. MBR partition tables support up to 4 partitions. When the PC boots up, BIOS looks at the first sector of the hard drive for instructions in the partition table to determine which partition contains the active operating system.
Thank you. Any other questions? This will help with the lag that we had there. No questions or doubts? So it's just basically slicing up the drive into its own pieces. Now, the MBR partition tables, help me out here, please. Joseph.
All right, master boot record, partition, primary partitions, MBR. Partition tables support two types of partitions, primary and extended. Primary partitions support bootable OS, while extended partitions are not bootable. A single MBR disk may have up to 4 primary partitions or up to 3 primary partitions and 1 extended partition. Primary partitions are usually assigned drive letters starting in C. Each primary partition on a single drive has a special setting stored in the partition table called active that determine the active partition. Grub boot manager is used to control multi-boot setups with one Linux OS.
Thank you. The Grub boot manager is basically the one within Linux, as he stated there. It is a software. There is another one besides Grub Loader. Anyone know who he is? Or Grub? I believe there's one more, right? What's the other guy? Lazaro? The old one? Because Grub is the new one. Anyone remember who it is? It was in the book.
A long time ago, there was one called Boot Magic.
I'm thinking about Lilo. Lilo was
Thank you.
Grub.
Lilo, yeah. Lilo and Stitch. How can I forget that guy? Lilo. So Lilo and Grub are, for depending on the actual flavor of Linux, are your two boot managers. No questions? Everybody okay? All right. Here is basically the extended partitions that you see on the bottom down here. You'll see that this one here are active, C, D, and E, or main partitions, versus the extended partitions or logical drives down here. The logical drives are unable to boot. So I could have an OS here, an OS here, an OS here, but not over here for booting. See now the complications with MBR, it is limited. Not only in size, but its capabilities.
So why do you have extended partitions? If not to...
Because the drives got bigger and bigger and you could only divide them so much. And then on top of that, those are the ones that I can use as extra space. For instance, if I had Windows installed in C, Linux here, and maybe some other Unix or even maybe OS X here, I can actually use these two drives to install all of my applications that I want to install, or to save information. For instance, my users folders could be over here, whatever I want over here. It has limitations in sizes, as we stated earlier. Does anybody remember exactly what's the biggest it can get?
That was 2 terabytes.
2 terabytes. How easy or hard is it to buy a 2 terabyte drive nowadays? It's pretty easy to buy one. I mean, I don't know. Actually, it'd probably be kind of hard, right? Because that's kind of considered a little bit smaller nowadays.
Okay, so C and E can be a maximum of 2 terabytes apiece.
C, D, E, F, and G. Each one could only be the maximum limitation per partition is 2 terabytes.
Okay.
So the features that it gave you here is that it allows you to create various partitions and boot up with on these 3. And then over here, the extended partitions, which are not bootable partitions, those you can use for obviously saving files or maybe installing certain applications if you like, whatever you want to do with those extra 2 terabytes.
Okay. And those are like universal between C, D, and E. C, D, and E can access F and G.
That is a trick question, technically. Depending on how it's formatted, yes, any partition can see the other partition, but you could actually hide them from each other. But technically, without doing anything and just leaving as it is, they should be able to see each other without any problem. Any OS should be able to see the other OS drive, and they'll be able to read, specifically Linux will be able to read Windows. And what we're looking here is primarily in reference to Windows setup and partitioning, just so we're fully aware of what we're looking at. So your dynamic disks, you'll see here now your question earlier, hopefully will be answered a little bit easier and understand what Windows has done with this. Can help us out here, Ronald.
Dynamic disks. Dynamic storage partitioning or dynamic disk create structures called volumes. The number of volumes that can be created in a hard drive is not restricted. Dynamic disk allow to implement RAID, span, stripe, or mirror over multiple drives. Only the lower end version of Windows 7 don't support dynamic disks.
Thank you. So if we look at that chart here, you'll see that with dynamic disk here, you can actually create RAID, you can do spanning, striped, or mirrored over multiple drives, and depending on which one you purchase is what it allows you to do. So without dynamic disks within Windows per se, for Windows to control the RAID function, it requires dynamic disks. Did that help? I think it was you, Alvarez. I'm not sure who asked the reason why we would use dynamic disk. Someone asked that earlier. We're good? Yes? No? It scares me when you're quiet. Hey, your GUI departitioning. Alvarez, help us out here, please.
GUID partition table. The Global Unique Identifier Partition Table, GPT, scheme is very similar to MBR, but it improves MBR scheme's limitations. You get an unlimited number of partitions, but Windows is limited to 128. Partitions larger than, and you also get partitions larger than the MBR limit of 2.2 terabytes. GPT is arranged by LBA instead of sectors. LBA 0 is the protective MBR, a recreation of the master boot record from MBR drives. So disk utilities know it is a GPT drive and don't mistakenly overwrite any partition data. GPT drives use a GPT header and partition entry array. Both are located at the beginning and end of the drive. So there's a protected backup copy. The partitions on a GPT drive go between the primary and backup headers and arrays.
Thank you. So that, as we see, GPT was a solution that was created. As always, Windows comes up with something to counter what we have created. As we see, GPT technically has unlimited number of partitions, but Windows can only handle up to 128. Partitions now are capable of larger than 2.2 terabytes. And GPT then creates what they say in the LBA 0 at the beginning of the drive. They create or mimic a MBR entry so that no other OS and or utility by mistake thinks that it's not there. Right. Within Windows, Windows can only boot from GPT on a UEFI based BIOS, or UEFI actually, BIOS is no longer. They must contain 64-bit versions of Windows in those different flavors, and obviously corresponding server versions. Within Linux, it does have its own built-in support for GPT, even though in the old BIOS, not BIOR, sorry about that typo, it can handle it in there or in the UEFI BIOSes. Reference to the Apple's, that APT that is no longer being used. What they are using and move to is to the GPT partitionings. Questions? Notice the limitations and irritations that you have with Windows. Those are the ones that are going to be killing a lot of people who try to do things. One key thing that it told us there was it has to be a 64-bit version of Windows, and it must be a UEFI BIOS for it to be able to do a GPT partition and be able to read it, I take it. Because you could have a GPT partition before that, right? Put it in there, it's not going to work. Right. When
I think I'm taking over on this one.
Thank you.
You said me?
Sorry, what?
Did you call my name?
Nope.
That he was up and to shut up. I mean that it was his turn.
To partition. The two common situations that require partitioning are: one, when installing an OS on a new system, or when adding a new drive to an existing system. When installing a new OS, the installation program asks how to partition the drive. When adding a new hard drive to an existing system, every OS has a built-in tool to help partitioning. Windows offer different tools for partitioning hard drives. CLI programs called FDisk is the oldest one. Modern versions of the disk manages under computer management and administration tools.
Excellent, thank you. Basically, just remember that, you know, when you're installing a new operating system or adding new drives, you're definitely that's when the main times you're going to be using the partitioning. On older systems, you use the CLI, which is the command line interface, and you would use the fdisk command. And then on newer systems, you would utilize disk management, which is a GUI interface system on most Windows operating systems nowadays. Any particular questions with regards to when you would do partitioning and where you would go to do this? Okay. And just to go over formatting, essentially it does two basic things. It creates a file system and makes a root directory of that file system so it knows where everything is going to be located. And then upon that, it will build everything else that you need. And if we want to remember from the last slide, where exactly does it put the MBR? When you are formatting and you are adding an operating system, where does the MBR go? Or master boot record?
The active primary partition.
And which one is, and what part of it? Library what?
0?
Yep, that is correct, Alvarez. So yes, primary partition, library 0. That is something that you will likely hear again. So I would remember that one. File systems in Windows. The disk formatting disk management utility is the primary system you would go to utilize this. If you wanted to carve out a section of the current hard drive you have and want to add an additional operating system to it, like if you want to, have a Linux machine on there, or you want to do a Hackintosh or something like that, you could go in, partition out the hard drive and install that on there. So that would allow you to have dedicated space for that. Or if you were adding in a new hard drive and want it, folded into the system, you would set it up within disk management. Current, versions that we use right now, replacing the old FAT system is FAT16, FAT32, NTFS, exFAT, or FAT64. All right, FAT obviously stands for File Allocation Table. The oldest one that it goes by, and it stores all information by sector. And each sector within FAT16 stores up to 512 bytes. So in this particular case, if you're putting in a file and say it's 530 bytes, it would require 2 sectors in order to be able to store this file. So you would have an additional like 20 or so bytes, and then on the remainder of that sector would have to be used up by additional bits. You couldn't store any additional file within that because it stores it by sector. And once it stores a file, it uses an allocation table to kind of let you know where the next file is. So if it's writing it as quickly as it can, so it's not all in the exact same place, there will actually be a table that you have that'll basically tell you, hey, here's where the next bit or the next sector is stored for this file. So it starts off at this point, and then it'll jump to another sector and tell you exactly where that file is. There's a nice little graphic on the next page we'll use to show you that. But one of the other things to keep, if its sector is good after you've formatted it, it will mark that sector with all zeros, letting you basically know that that sector is now available. If it is a bad sector, it will mark it with FFF7, letting you know you cannot write to that sector. It is a bad sector, no longer able to be used. And as it's using the 16 bits, we operate in hexadecimals for the file table. Clusters. The 16-bit is limited to the 64K or the 512-bit sectors, as we were just talking about. And clusters is a group of sectors essentially operating as a single unit, and they don't necessarily mean they are right next to each other, but they can be in other places, but they are grouped together, and a sector is essentially a group of bits, if that makes sense. All right. Here's a pretty good look at the sorting, how it sorts the data. Over on the rightmost side, you will see what a disk sector will look, or a disk will look like. Right after formatting, if you see all on one side, it has 3ABB. That would be the name of the cluster in the file. And then right next to it, you see status 0000. That lets you know that that cluster is available to be written on, which is why if you see all the way down, almost all those sectors are zeros because the drive has just been formatted. And then on cluster 3ABD, you see next to it the FFF7, which will let you know right away that that sector is bad and cannot be written to. So when the drive is writing, when you're writing to that drive, it will skip over that sector because it knows that that sector is bad and no longer able to be written to. The very next column you see, it shows you a little bit about how data is stored. So there's 3 different documents in this particular one. You have the mom.txt, you have the IRS, I guess it's tax document, and then the IBM help document. So if you go up to the mom.txt, you see the first part of that document would be in cluster 3ABB. And that is where that document is starting. That's where you are initiating the writing of that document. Now it has exceeded the size of that particular cluster, so it needs to go to the next one. So where you see status in the very next section, it says 3ABC. That tells you where the very next cluster that document is stored in. So if you jump down to 3ABC, there it has continued to write. And then over in the status, you see 3ABE. So it's skipping over section 3ABD because it has the FFF7 in it, which is, as we were stating earlier, that is a bad sector. So it is unable to write there, so it has to jump to the very next sector to write. And then it says 3ABE. And now, when you've come to the end of a document or a file or whatever, they put FFFF, and that lets you know that that is the absolute end of that document. There are no more sectors you need to look for. Are there any questions with regards to how the FAT16 stores the data and how it looks for it in this file system? Okay. Okay. The next column right here would show you essentially like if you had deleted a file, it essentially creates a fragmenting within the system. And, but the file table will tell you exactly how to find the files. So you have the 3ABB, the status tells you to go to 3ABC for the next section of that file. You jump there, then it goes 3ABE. So you jump all the way down to 3AB, skipping over the bad sector file that we talked about. And then it'll tell you 3AC4. So you have to jump all the way down to 3AC4 to find the remainder of that document. And this is what a fragmented file would look like. And in order to correct this, you would actually run defragmentation to put all like clusters or contiguous clusters together so that they're easier to find and locate for the system. Are there any questions with regards to fragmentation?
Is fragmentation where it say 3AC7, is that the new start of a new format or something? The reason why I have all
3AC7? No, 3AC7 where it says 000, that lets you know that that actually is an open sector or cluster available for writing. So that one is available. But if we're looking at this one file, this taxrec.xls, so if you go to the top, it says the 3ABB. That's where the file starts. That's the initiation of that cluster. And then the file is larger, and then the very next section over it tells you the status, 3ABC, that tells you where to go to look for the very next section of this file. So you go there to the 3ABC, which is right below it. And then there's that one in the cluster. And then over in the status next to it, it tells you the next place to look for the next section coming up after this one, because we're still working on the same file. This is all the same file. This is just the different places in which it's working. So the reason it didn't write in 3ABD is because, as you see in it, it says the FFF7, which lets you know that that is a bad sector within the disk. So we can't write there, so we had to skip over it. And that's where we went to the 3ABE. And then in the status for 3ABE, it tells you the next sector you need to go looking for the remainder of this file is 3AC4. So we have to skip over all those segments in between all the way down to 3AC4 for the next section of this file. And then in its status, it tells us where to look for the next segment in line, which is 3AC5, which is right below it. And then the final section below that, after it tells us 3AC6, there's 3AC6, and then in the status, it gives us FFFF, which that is the indicator for the end of that file. We don't need to look any further. The end of the file has been reached. And if it didn't use up all 512 bytes of that last file, 3AC6, it would just fill them up with, I think, zeros to basically fill up the rest of that cluster. The rest of that cluster essentially becomes useless at that point. Are there any questions with regards to that?
No, that was all. Thank you.
Okay. The key takeaway here is just basically knowing what you're looking at when you look here. When you see a file, you know that, the section all the way over on the right, that's essentially what a drive is going to look like once it's been formatted. It's all zeros, basically letting you know the drive is open and ready to be written to. And then when you have a bad sector, it writes FFF7 to let the system know that this sector is damaged and it cannot be written to. Any questions?
So when you, let's say you reformat a drive, that doesn't repair any of the bad sectors?
No, well, I mean, it may repair some, but some are not able to be repaired. And so if it is unable to be repaired, or it is just a straight bad sector, it writes this status to it to let the computer know you cannot write here. If you do, your data will not be recoverable.
Yeah, I just wanted to know if actual formatting would fix it. So you got a bunch of bad sectors, would it fix it and you're back, you know?
Some cases, yes. Some cases, no. I mean, it depends on the level of damage.
Okay.
Also, as you start getting more and more bad sectors, that's a sign that your drive's going out.
Yeah.
Absolutely. Absolutely. Yeah, well, if there are no questions, ice cream truck is driven by a couple times. Oops, let me go ahead and start recording. There we go. One other thing to also note about FAT16 is it allows for a maximum partition size of 2 gigabytes. Not terabytes, gigabytes. So that would be your maximum partition size for a FAT16 clustering. On to FAT32. Marvin, is there any way you can pop that back up screen share? I don't know if you were the one sharing before, if it was Diego.
I can put it up 1 second. Okay, Diego got it.
Okay.
At least I think so.
Beautiful background, Diego. I don't know if we're...
Oh, this moved the numbers again. This is too funny. How about that one?
That's better. I like that one better. I mean, the other one was a nice picture, but it's not really going to help us.
Yeah, you can only dream that you're at the beach, right? All right.
Yeah, that's true. That's true. Similar to FAT16, FAT32 essentially doubles the amount of bits used to describe each cluster. And instead, unlike FAT16, which only allowed 2 gigabit partitions, FAT32 allows up to 2 terabyte partitions. So it allows you to use your disk space a lot, more efficiently. You don't have to have, a bunch of small partitions within your drive just to be able for the system to be able to support it. As well, it is still heavily used today. FAT16, not so much. Did I lose everybody?
I still.
My Zoom resync, so I just making sure. All right. So
good.
FAT32 is still commonly used today, unlike FAT16, which is rather rare to come across it today. But FAT16 is not typically used, for hard drives or actually within your computer system. We actually use it for, I would say, smaller USB drives that are essentially 32 gigabytes or less. And that would typically be the clustering system that would be utilized on these smaller USB drives. Any questions with regards to that?
Yeah, I have one question.
All right. Okay.
I don't quite hear you. How much space does a FAT32 have in one drive?
In one partition, you mean?
One partition, yeah, sorry.
It allows up to 2 terabyte partitions.
Okay.
But the file system is typically used on smaller USB drives, smaller than 32 gigabytes. That is where you'll more commonly find it. All right, next, we get to the one that is most commonly used today on computers and desktops, which is the NTFS, or New Technology File System. It uses the cluster file allocation. It's far more complex than FAT1632. It allows all sorts of fun things like security, compression, encryption, disk quotas, and being able to adjust your cluster sizing. It's, like I said, it's the most common one used today. It actually allows file systems to talk across, like Mac and Microsoft to actually talk to each other and see. Otherwise, if you're using something older like FAT64 or exFAT and you try to do something like that, a lot of times Apple or Mac will not see it. So if you use something along the lines of NTFS, it actually allows these systems to talk to each other. It is a more recognized system. Let's see here. Alvarez, can you please read from structure?
All right, NTFS uses an enhanced file allocation table called Master Filed Table, MFT. NTFS partitions keep a copy of the MFT in the middle of the disk to reduce the chance of losing the MFT and its copy. Security-wise, NTFS views individual files and folders as objects and provides security for those objects through Access Control List, ACL.
Excellent, thank you. And anybody want to take a guess as to why they would put it in the middle rather than the edges? The master file table.
Is that where the disk is written to the least?
The edges would be where where the sections would tend to get damaged more, yes. So in the middle, it's a more secure place because they're not being written to as often. Is that correct, Diego? Excellent. All right. And as we mentioned earlier, it allows for compression of individual files to help you kind of save space. And the NTFS also allows for encryption file systems. And it is these security features which actually makes it so you really cannot use NTFS on external drives like USBs and stuff like that, because the encryption and compression and stuff like that makes it hard to actually allocate the files properly. So you typically will only see NTFS on internal hard drives, not on like USBs.
Yeah, and your writes are another problem. Your actual ACL will be used from the actual computer. So then when you go and stick it on to another computer or give it to somebody else that has obviously on a domain, they won't be able to use it because the ACL will not be the same.
And it uses, what was it, the TPM, the Trusted Platform Module?
For the encryption,
is that for
yes.
BitLocker specific?
The encryption for BitLocker and for the EFS, that is correct. It uses the TPM. And since each TPM is hard-coded, it won't have the key. It's not going to have the key.
The TPM is specific to that motherboard within that computer.
Yeah, Trusted Platform Module, which hopefully we all remember who he is.
And it allows, by default, partitions up to 16 terabytes. So we had the FAT16, which allows partitions up to 2 gigabytes. You have FAT32, which allows partitions up to 2 terabytes. And then NTFS, which allows it up to 16 terabytes on a dynamic disk, though only on 2 terabytes on basic disks. Any particular questions on NTFS? So most common in use today, used particularly on actual desktops and laptops in the actual internal hard drives, not typically seen in external drives. And then when you get into smaller USBs, you have FAT32, which is typically used for externals and smaller USBs. And then you have FAT16, which is rather rare to actually be in use today. Any other questions? All right. Finally, we get to FAT64. And since FAT32 only supports drives up to 2 terabytes and files up to 4 gigabytes, they had to create a new file system. So they have the new exFAT or FAT64. And typically you will see this on larger USB drives, like ones that go to like 124, as we're starting to see those far more common now. And as the FAT32 can't handle it as well. And the most common, like I was saying, in external large capacity file systems, it allows for 64-bit clusters, and I'm not sure what the maximum file size is on it. Is it 60? What's the maximum drive on this one, Diego? I'm sorry, I'm having a moment where I'm
maximum drive space in which one? I'm sorry. In a FAT64?
Oh, sure. Okay. Yeah, for 64.
I don't think 16 there is a limit. 16 exabytes. Okay. But that's the files.
There you go.
That's not the partition.
Files.
Oh, 64 zettabytes is what you want.
That's a lot. Yeah, okay. So 64 zettabytes typically for external drives and removable drives. This is going to be one of the more common ones you see. If it goes over 32 gigabytes tends to be that breaking point where they will jump up to FAT64. Or exFAT, same thing.
If hopefully we remember the chart on the different sizes of Yoda bytes, zettabytes, exabytes. These are not made up words. These are actual sizes.
Mm-hmm.
So that's pretty ridiculous, 64 zettabytes.
Yeah, that's a lot. All right. And with that, I will hand over to Marvin, if you are ready, sir.
I am ready. Here we go. Other formatting options. Wait on my PC to change. It hasn't changed yet. Let's see. All right. So Kelly wrapped up Windows. It's now my turn to talk about Linux. And as it's stated here, Linux uses the file system ext4 by default, but 2 and 3 with their older distros, and they are still available. Linux, fortunately, can read all the other ones, NTFS, FAT32, 64. Let me not say all of them. I don't see 16 there. But Windows is not able to read the ext4, but there's a way around that I recently read. Now, the strengths of using this particular file system is that it supports volumes up to 1 exabyte and file sizes up to 16 terabytes. That's uber big. Yeah. And it contains directories of up to 64,000 subdirectories, and it improves on the ext3 format. The ext4 does. Now, as I'm reading this, if you have a Linux system and you plug up an external drive that has a different file system, Linux will read it. But if they're sharing, or if you need to put Windows, if you're using Linux on Windows, you have to run a Windows driver in order for it to effectively communicate with that file system. One of the drivers I found, and probably is used a lot, is ext2fsd. Diego, if you will allow me to share, I'll bring that up right quick. Let's see here. Share. go. Are y'all able to see it? I need a thumbs up or something. Okay, gotcha. So as it stands, like I told you that it's a file system driver for the 2, 3, and 4. And once you load that up, you're able to actually read that file system on that volume on your PC, which is pretty neat that they figured out that was the way to do it. So it really cuts down on a lot of hassle was trying to have both of those if you have them on your PC. So once you create that volume, you can actually have that file system there. And I wanted to highlight that sentence right below this one. It says that it's actually the default ext4, like the slide said, but it's going to be able to read it, even though because it's reading it as something else. It's not reading it as the 4. So wanted to show that.
Now, why would I want to do that? If anybody can take a wild guess, why would I go out of my way of making sure Windows sees that F drive? Anyone want to take a wild guess why I want Windows to see that F drive?
Share files with yourself?
Oh, well, that would be a nice, cute little benefit. What happens if I run out of space and I go into Disk Manager and I decide to partition and use that space? What do you think is going to happen?
In order to resize partitions, it has to be able to read it.
But correct. But if it doesn't see it, the partition exists. And since I can't really see that there's something there, I can use it. There's nothing there. Therefore, when I go to Disk Manager, that space of the local disk F, since I can't read it, technically there's nothing there for Windows. And now I can actually partition, allocate space, mount it onto anything, and effectively destroy what was there.
Without jumping too many hoops there. That makes sense. All right, let's see. Other options. Chris, if you don't mind, I'm gonna let you read both of those for me, sir.
Other formatting options. Sorry? Good.
Yes.
Other formatting options. CDFS, UDF. While not a file system that can be used on hard drive, CD-ROM file systems, CDFS, is the file system of choice for CD medium and has been used with 32-bit Windows version since Windows 95. DVD drives and Blu-ray disc, BD drives, use the newer Universal Disk Format, UDF file system. NFS, Network File System. NFS is a distributed file system protocol originally developed by Sun Microsystems. It makes possible for files on the network to be accessed as easily as if they are stored on a local computer. Even if the host computer uses a different OS, such as Unix, the network share still functions.
Thank you, sir. And you can see how that can be very beneficial in an enterprise setting. So you still have access to those files using that NFS network file system. The takeaway from the first paragraph is to understand that the CDFS is for CDs, but when you step up to DVD and Blu-ray, you have UDF as the file system. Just throw that in the back of your head. CDFS makes it kind of easy to identify. So just know that it's just for CDs, and anything else has a different filing system.
And don't get caught in the trap where you're on the exam and you're like, what kind of file system they use for CDs? And you be like, CD, it can't be that easy.
Right.
There's no way. And then you discount that one because you think that there's no way they would name it something so simple.
Right.
So definitely keep that one in the back of your mind.
Because I can say I do, when we go over these Nearpods, and Kelly Diego, I know he takes for refreshers, and last week we recently took the test, so we're seeing things that like, oh, I saw that. It will come up. So CDFS is very simple, and like Kelly said, don't let it bother you that it has such a simplistic name. We take the wins when we can get them. This next slide is going to talk about something that Alvarez spoke on. So I'm going to let Alvarez read it.
All right, quick format versus full format. When formatting storage devices is possible, when formatting storage devices is possible to choose between a quick format or a full format. With both formats, files are removed from the partition. The difference is that a quick format does not then check for bad sectors, which is a time-consuming process.
They help you out any, Alvarez?
Yeah.
Knowing that you have the ability, if your drive is healthy, otherwise healthy, you can do a quick format. But if you are concerned, maybe it has some age on it, maybe a number of things, go ahead and run a full format to ensure that those bad sectors are acknowledged and addressed, and it'll probably give you some peace of mind. So if you're not like on a time crunch, just do it anyway, So you'll be able to walk away. Mm-hmm. And this is just showing us what to look for when we go into the disk management, and we have the ability to create that volume. So you look down there, you got NTFS, FAT, FAT32, and exFAT. And that is highlighted to perform a quick format. So if you uncheck that, it would do the full one. All right, now we're going to talk about some troubleshooting of these particular formats and drives. Okay. If David, if you don't mind, sir, if you'll read this one for me.
Troubleshooting implementation, partitioning. Partitioning errors generally fall into two categories: failing to partition, making the wrong size. To fix a partition problem, open disk management and do the partition correctly if the problem is in a secondary drive. If the problem is in the OS partition, use command line interface or Windows installation tools.
Anybody understand why you would have to use the command line or the Windows tools if it's on the same partition as your operating system? Like it's no way to address that issue if you're dealing with that primary partition. But as a secondary, you can run the disk management and address the issue. So, and we talked about that. What was the two things? Where are you? Is Joseph here? Yeah, what was the two options that you see if you gotta do some type of installation in the beginning? We talked about it. I think you was one of the ones that got it right, Joseph. Was it it was a custom, and what was the other type of format?
Oh, I know what you mean, custom or upgrade.
An upgrade. So you can only address it using Windows tools, thank you, Joe, or using that command line interface. So you'll actually have to go into the command prompt and type it in, because that's the only way you can communicate with that same partition. Appreciate it, Joe and David. Got some more here. Muhammad.
Yep. Troubleshooting implementation format. Failing to format a drive makes the drive unable to hold data. Accessing the drives in Windows result in a drive is not accessible. Either or, invalid media type, error. Corrupted files can create the invalid media error.
Thank you, sir. And
no problem.
I don't know if you've seen this, but this is a one of the things you can tell if by any chance you're having issues with connecting with a drive over time. And to address this, if it's not the primary drive, we can utilize that disk management again to see if we needed to do a quick or a full format. In this case, I'll be looking to address it in a full format type setting. So these are just things you could possibly see in that process of dealing with your drives. I think this might be my last one. Physical problems. Ms. King.
Physical problems in hard drive manifest themselves in several ways. Read and write failures, loss of noise or drive seems to disappear. The symptoms. If mechanical drives begin to make any of the following sounds, it is about to die. There's continuous high-pitched squeal, a loud clicking noise, or short pause, and then another series of clicks, continuous grinding or rumbling. The solutions. If hard drive is about to die, the solution is to back up the data and replace the drive. Or when a hard drive is with the OS dies, the system will lock up. It gives error, no boot device present. And if it's a second drive, it will stop showing up in Windows Explorer. In that case, both power and the data cables and connectors should be checked.
Thank you, ma'am. Someone about to say something? If you hear a grinding or a rumbling noise coming from your computer, I truly feel bad for you because I don't know if you'll have the opportunity to try to back it up. You've reached a point that you may not be able to return from, but as long as you can see it, you can address it. So at that point, I would limit my time on it until I'm in a position to go ahead and follow through with the solutions that Ms. King just mentioned. And I need to address this drive. I need to. And I think we had a question about this on either a Kahoot or a talk, Kelly, I think with the clicking, when we was thinking about it was the fan or something, the power supply or something like that. I think that was one of the questions recently we had. But
well, it was the fan, and if it was the rhythm, we had the rhythmic clicking. You know, it's the hard drive.
Right, that's what it was.
But if you've recently done repairs on the computer and you're hearing that clicking sound, you could have dropped debris down into the fan.
There you go.
Like a screw or something like that.
But if it's not showing up in your Explorer, your hopes that, like Kelly just said, if you've recently done some maintenance or some things, maybe the SATA cable or one of the cablings is become dislodged. Highly improbable, but possible. Right, there you go. Anything's possible. You want to check those things. Do you remember the conversation we had with the young lady who couldn't get the monitor to work in the other class, and she left out the fact that she recently moved? Just something to think about. I think, okay, now we have a test here, a little quiz. I'm gonna unshare and let you go through that really quickly and we'll talk about it. While you guys are doing it, I currently have a 250, 400 gig portable hard drive, and I've had it for quite some time. And it's to the point now where when I plug it in, it spins up. I see all of that information, and I'm purposely trying to take bit by bit and move it over to another hard drive before it like disappears, because it'll spin up, let me see it, and then it'll just disappear. And you'll hear it wind up and then you'll hear it click. So it's a grueling process, but I'm halfway there because that drive is no longer, it's gone. It's at that point, so. So it can happen. We're getting close to finish. I see quite a few people done now. Hey, Diego, if you're able, just, shake your head. I see your name as a student. Did you want to go through it as a student and answer? Okay. Then we just got a few more that need to
help me out. As always, somehow I get amnesia. So somebody help me pass this test, please.
Are we doing it now or some more time?
I think
whoever likes to answer number one, help us out.
They don't see it. It's not up. I think you got to share.
I see it.
Oh,
I can see it.
Okay, good. Why I can't see it?
I probably chose B on that first one.
I agree.
We have a second. I chose B on this one too.
Yep.
Everyone agree?
Yep.
All right.
I chose C on this one.
Yep.
I chose D on this one.
Yeah.
Was a Kahoot question as well. I don't know if you guys remember that.
Yeah.
I think they all were Kahoot questions except for this one. I chose A on this one.
I did A too, but I wasn't sure.
Yeah. To extend, I mean, that's a cheap way to break the NTF drive capability, is to extend the partition. It was added after the drive stuff came out.
Okay. If you don't mind checking me out and see what I got, Marvin, which we might be surprised. You go ahead and share. Hit the button share on the left or wherever it is, that circle. There's a circle and there's a red button that says share.
I'm going back to it right now. Oh, here we go. And hit share.
No. The other way around. Nice.
Oh, I see what I did. I didn't supposed to share my screen. I was supposed to.
Yes, silly.
Gotcha.
There was a button that says just.
So what is the last one?
Probably the dynamic.
Now let's be very careful on what we said. An extended partition we said was what? Does anybody remember? What is an extended partition?
I thought it was another partition.
It is.
It's just a non-bootable one.
Well, extended partition would be, to me, would be.
It was the one where you create it as another drive and somehow something as a folder, mounted as a folder.
Interesting. Now
but that wouldn't add capacity. You're just changing the size, but you're dealing with the same amount of space that you had, no matter how many partitions you create, right?
No.
You'll be surprised now on what was going to happen. An extended partition, we all agree, we had that picture with the C, D, and E, which were primary partitions. An extended partition is one that does not boot, right? Therefore, it's really its own drive letter, and it will not give you more space to that drive letter. One way to be able to resolve this issue, whenever you had an actual server and or anything else that was doing this, was what our friend just alluded to, and that would be install a second drive and mount it into a folder on the original smaller NTFS. It helps only, like you said, that given folder. So now I can actually put it into the marketing folder per se, and now that marketing folder, they're not going to know it's a folder inside there, and they have no idea. What can I do? A lot of the times we went and grabbed all of, let's say 2021 just came in and it's accounting. So we grabbed all of 2020, threw it into that other folder, which they thought was still a folder. And it's actually another drive with all of the archive containing 2019 and any other stuff. And then obviously leave the original folder where it is. User has no idea what's going on in the background. Obviously, the operating system is just tricking them to think that it's actually a folder when it's not.
So it's just a map drive, in other words.
It's really a folder. You're mounting it. It's like if you mount on top of a horse, you're on top of the horse. You're putting it physically inside there. So it's not its own drive letter per se.
Well, yeah, I understand that, but when you map a drive, you can put it into folders. Yeah, okay.
When you map a drive, it's really a virtual connection or a shortcut to a shared folder on another server or host with whoever is deciding to share that, right? So all that map does is it creates a letter that it assigns on the PC. And for instance, you could put the letter G or something like that. Now it mapped the drive there so you can use it without having to put the server name again or any of that other mumbo jumbo. It already has the piped direct to that share. Compared to when you mount it, all the user sees is a folder inside their share folder, whatever it is that's in there. It's just a folder. To them, it's just a folder. I think there's even exercises and or some activities that you guys can do. And we could obviously do this with our virtual machines too, if we like. Create a brand new drive or dynamic disk, a second one, and mimic the exact same thing. Once again, they gain that space. It's not on the drive, but since it is mounted to that folder, what that virtual space or the real space is similar to, you know what you could think of it, Chris, if you really want to think of it, it's similar to being a shortcut to somewhere else, but they're not going to see it as a shortcut. Hopefully that helps you out.
How many times can you do that on a partition? Like how many folders?
Mount?
How many
you can mount whatever you want.
So you can
mount whatever you want.
One partition?
That I'm aware of, you can mount whatever you want onto any folder. I'm not seeing it, that I've never heard of any limitation of you mounting to. Remember, you're just creating a folder inside that given drive.
Right.
So it's going to be able to use that whole drive as if it was a folder. Well, depending on how much, obviously, whatever that partition is.
So you get like 3 separate drives and added to that as 3 separate folders within that partition. So that'd be a way to hide your drives. Okay.
And without having them to go to a different share, without having to recreate new folders, without having to move data around, all you did was just put that extra drive in there and you mounted it into the folder and voila.
All right.
Questions or doubts? That was the only one that usually throws everybody off if they've never done that one. All right, guys, I could torture you for another 10 minutes, but I'll stop it here.